Hello, this is how to use .NET 9's ASP.NET Core in order to create web applications on Ubuntu 24.04. This is the wiki page of .NET. So .NET is the continuation of .NET Core, is different from .NET Framework, and can be installed and run on Linux operating systems such as Ubuntu 24.04. I searched on Google for .NET. It took me to this web page, .NET.microsoft.com. In here we have this button where it says Web, Build Web Applications for Linux. Click on it. It says Get Started. And it takes you through a tutorial. Let's follow this tutorial. Says that in order to create a .NET application that uses ASP.NET Core, Blazor.NET 9, we will need to install some prerequisites. So the software development kit for .NET 9, we will use Visual Studio Code and extensions inside of the Visual Studio Code integrated development environment. Let's go through the instructions. Install .NET Software Development Kit on Linux. That's correct. The following Linux distributions officially support .NET and have their own .NET packages. Let's see the difference between the packages which are provided by Ubuntu, so first-party dev packages from the Ubuntu official repositories, or we have this alternative with installing the Ubuntu Snap or the .NET 9 SDK. The article about .NET SDK with the Ubuntu Snap says that because of the Snap confinement technology, there are some limitations. There are issues with .NET Watch, with running various .NET tools. So we'll try to not use that. Then for the installing Linux using Ubuntu deb binary packages from the official Ubuntu package repositories. It says that for the version that we're having, which is Ubuntu 24.04 LTS, inside of the built-in Ubuntu feed, there's just .NET 8, but we need .NET 9, and that is available in another Ubuntu feed, a PPA, that's compatible with the default Ubuntu deb repository. So we probably need to run this thing. Let's see what it says. So a new deb repository of type deb, so not deb src, will be added. PPA launchpad.net backports Ubuntu. We have 24.04 and .NET 9, which is supported for 1 more year. Enter to continue. Apt update is being run automatically. So we can just start installing packages. Let's look at the list of dev packages available from this PPA. We expand technical details about this PPA. Open this URL where the dev packages are located under pool main D .NET 9. So I'm going to guess that this .NET 9 is a source package, and these are deb packages. So there are deb packages for AMD 64 and other architectures. And the package names are ASP.NET Core Runtime, .NET Host, .NET App Host Pack, etc. And then there's .NET-SDK, .NET-Runtime, in here it says that if you're not editing .NET applications, the better runtime is ASP.NET Core Runtime, so this one, because this includes the .NET runtime. So this is a superset of these. If you want to just run ready-made executables and .NET DLLs, but if you want to actually create .NET executables and DLLs, you will probably need the .NET SDK version 9. Back to the instructions on how to install .NET on Linux. You select Packages, Ubuntu, scroll down 2 pages. It says that I'm using Ubuntu 22.04 or later, and I only need .NET. Suggest that we use the Ubuntu feed, which we do. Select install .NET on Ubuntu 24.04, and then the same recommendation that if we want to create software, we need the SDK. Otherwise, we should install ASP.NET Core Runtime, which is a superset of the .NET runtime. Packages for Ubuntu 24.04. We did add .NET backports. And now we need to actually install the package .NET SDK 9.0. This is the deb package that's going to be installed, AMD 64 deb .NET -SDK -9.8, and then a version. We could just copy paste these lines. Again, no need to run apt update because add apt repository has already run apt update, but it's benign. Apt update will just download the metadata, so the list of packages that can be installed from deb repositories from Ubuntu. It installs from that PPA many deb packages. ASP.NET Core Runtime, .NET Runtime, templates, targeting pack, host, FX, host frameworks runtime FXR. Okay, so 13 deb packages need to be installed, 131 megabytes in size. We'll be back in a second. So we've installed .NET SDK for version .NET 9.0. We don't need to install ASP.NET Core Runtime or .NET Runtime because these were already installed. let's continue. So we have .NET 9 installed correctly. We should continue with the tutorial. We need to install Visual Studio Code, which is an integrated development environment from Microsoft. Let's try installing from the Snap Store. Let's see how we install this thing. Click on the button Install. Probably just this command line is needed. Let's see. This seems to be doing the installation correctly. So it's installing Core 20, which is what? Which is the Ubuntu 2020 or 4. Snap base. The name of the snap is Code, so Visual Studio Code. And it requires wide access outside of the snap confinement. And it does that by specifying that it wants classic access. And this is approved automatically. So in this way, the text editor, the integrated development environment of Visual Studio Code should be able to see all of the directories because it will need to edit files in both in my home directory and outside of it. Okay, so now we have Visual Studio Code. Open Visual Studio Code. Let's see how we open it. Code. This guy. Authentication required because why? I don't know. This is the first run of Microsoft Visual Studio Code. It's showing the welcome screen. It asks some settings. Done. Okay. Show welcome page. Close the welcome page. Next up, it says that in Visual Studio Code, I should install extensions. So this is the extensions button. Type C#. And it offers C# dev kit. Install. This is an extension package containing many other Visual Studio extensions. Okay, while that is running, we want to download and run a configuration file. I'm not sure what that thing is. Seems like an empty chapter. We need to open a new terminal. The C# dev kit Visual Studio Code extension has been installed, so let's see. In the toolbar, select terminal, then new terminal. Is that. Okay. And then let's see if .NET is available. Okay, so it's here. Info. .NET 9 /usr/lib/.net /shared. Wow. So inside /usr/lib should have been native SO files, not cross-platform DLLs or something else. And why would there be a shared directory under /usr/lib when there's a /usr/shared directory? Okay. Seems that we can continue to the next step. We want to create an application. So let's do that. Open the VS Code command palette, Ctrl-Shift-P, which is this thing. Type .NET. .NET new project. This element. Says that it will download additional, probably, I don't know, templates or support inside the Visual Studio Code for .NET and .NET ASP.NET Core. Blazor web app. So we want this thing, Blazor web app. Okay. So we should select a directory. How do we do that? Yes, not the select folder, which is a combo box, but the open button. Blazor app 1 seems okay. Create project. Trust. Let's not sign into the Visual Studio subscription. Visual Studio Code Explorer, this guy. So the tool window Explorer, Ctrl-Shift-E. Blazor app folder and a solution file. So this is very similar in structure to the Microsoft Visual Studio solution, even if it's used inside Visual Studio Code, and it was created by the .NET command line tool. Blazor app project. What are you trying to do? So this was because the extensions that we have just installed, which are the best extensions for C# from Microsoft for Visual Studio Code, add another tool window to Visual Studio Code. By default, when you open, for instance, a directory in Visual Studio Code, you get this view, Explorer, Ctrl-Shift-E, and then Outline and Timeline. But then additional, added by this extension, is this view, Solution Explorer, which is a viewer for SLN files, for CSPROS files, for ASP.NET Core projects, etc., for projects generated using the .NET command line executable. So this suggests that from now on we use more Solution Explorer than at least Timeline and Outline, maybe even more than just plain Explorer. So it suggests that we move this tree view item at least above the outline tree view item. That's what it says. It means when it says drag and drop Solution Explorer, you need to drag and drop this element to make it easier to be accessed. This is what they have here. On the first tree view item is the actual Explorer, which is the directory that we have opened, which is directory 1 in my case. And after below that is the Microsoft MS Build Explorer, Solution Explorer. Okay, let's see the files that have been generated automatically. This is just a ASP.NET 9 Core sample Blazor application. It starts with program.cs. It's actually generating a DLL file and a small executable file. You can run the entire website as a command line as a command line process, because we have the access that we can run. By default, when run from the command line, it will use HTTP, not HTTPS. It will use the port 5000 probably, and it will use the HTTP server from Microsoft that's built into ASP.NET Core, which is called Kestrel. When run from a debugger or from an integrated development environment such as Microsoft Visual Studio Code or Microsoft Visual Studio, it will use different settings. It will allow, for instance, integration with IIS Express. It will have a development configuration. It will have the possibility of choosing between a HTTP protocol and a HTTPS self-signed certificate for development purposes. So this is just a command line executable in C++ in C#, but it's using top level statements. So this is actually the method of the class program, the method named main. And these are usings. So it's preparing a builder, then it's preparing an app, and then it's running the application. The app is of type web application. There's configuration files, one for the configuration development, another one for the configuration production, static files such as PNG image files, CSS, JavaScript files. So files that do not require any server-side scripting. Components is a keyword that means Blazor files with extension Razor, such as the counter. We'll look at the Razor files immediately. And then there's properties, which is about how the application is configured when it starts. So it's a web application, and when run in just by starting it from the command line, it will serve on port 5000 and use HTTP only, whereas when run from an integrated development environment in development mode, it has these two different profiles, HTTP and HTTPS. both for the configuration development. And then for dependencies, it depends on ASP.NET Core and .NET Core. Okay, let's go to the next step. Select Run and Debug in the activity bar. Run and debug. Select the blue Run and Debug button, this guy. You don't have an extension for debugging JSON because the JSON file was opened. Let's ignore this suggestion. So back to where we were, Run and Debug, Ctrl-Shift-D, the blue Run and Debug button. It offers these ways of running. It doesn't say anything about HTTP or HTTPS. Doesn't say anything about debug. Okay, so the order is a bit different. First, it shows this list, this combo box where we should select C#, and then it offers the configuration. So development HTTPS, development HTTP, and the production one. It says that we should select C# Blazor default configuration, which we do. The application is starting. It builds the SLN using configuration debug any CPU. And then it starts with port 5105, TCP, and protocol HTTP. So indeed, we can see that the chosen protocol is HTTP, not HTTPS. And we can also see that the HTTP server is named Kestrel. So this is a high performance HTTP, HTTPS server with tons of new features. And this is the production HTTP server that will be probably used by your ASP.NET Core application. Let's look a bit at the running ASP.NET Core .NET 9 Blazor application. Has a main menu in here, about box, just shows you, just navigates to an external URL from Microsoft. And then the menu, home, counter, and weather. So home is showing mostly plain text. Counter, it's showing a button. Where does this state reside? This 7 on the client side, inside the web browser, or inside the web server side? Weather is showing a grid. Let's look a bit at the source code. So in Solution Explorer, components, imports.razor contains a list of .NET using statements. Routes doesn't do much because the routes are actually defined inside the .razor files. Up.razor is the main layout of the page. It has these Blazor classes inside, so routes, outlet, and import map. Let's look at the page source. So it starts with doctype HTML, HTML language English, head, meta, charset, viewport width, slash, style sheet, bootstrap. The character at is for source code that will be interpreted and executed server side. So this URL for lib bootstrap dist CSS bootstrap means CSS, so this thing. The correct path to this file is being computed and is just itself, doesn't need to do to put any prefix. Okay, the same for app.css and then for Blazor app1 styles.css. It actually puts these global unique ID things like before the extension CSS. Okay, import map is these guys. This guy. Link rel icon, image PNG, fav icon, and then head, which is this thing, just the title. And then you close the HTML tag head, then body, and then everything ends with framework Blazor web, end of script, body, and HTML. So this thing. The rest of the HTML body, so starting from body and ending before the final script, is content generated by the rest of the .razor files. We start with main layout, div class page, div class sidebar, and then we have nav menu, which is a Blazor object class, which is defined in a file with the same name, navmenu.razor. Navlink is a Blazor type, a Blazor class that's defined by inside ASP.NET Core, Microsoft.ASP.NET Core.components.routing.navlink. Okay, then main layout continues with, so nav menu will put the left-hand side menu, this guy. And then in this rectangle, it puts the at body, which is the individual pages. For home, there's just some plain text, but the page title is needed because it's exposed in here, head outlet. This is for the body, h1, and then some text. Next up is the counter page. So counter.razor again has a page title, and this is a bit special. So Razor has route, home.razor has the route slash, whereas counter.razor has the URL slash counter, as we can see in here. So this is the route. This special thing is interactive server mode, which means that it's not a simple server-side rendering. So the server side will generate a number of HTML files and those will be served via HTTP. No, there's additional functionality after the HTML files have been generated and served via the HTTP server. We have unidirectional or bidirectional connection between the web client, which is the web browser, and the web server, the HTTPS server, via signal R, via long polling, etc. Okay, so this is actually a C# class counter, named counter, that has a private int field and has this private method, and the method is invoked on the onClick method of this button. So button is part of the HTML, whereas at onClick is part of Blazor. Or a simpler way of calling C# source code from HTML events. Okay, and then this thing is rendered as this thing, so plain HTML, and then a concatenation. This thing is evaluated on the server side. This will be incremented each time you click on the button click me. So let's say that the current count is 2. So in here, this thing will be replaced with a string 2, and then this thing will be concatenated. And then the entire HTML page will be sent from the server to the client, or via the interactive server connection that the client, the web browser has to the HTTPS server. Only incremental differences or deltas will be sent from the previous version of the file, which said that current count is 1, and now the current count is 2. So in fact, only the character 1 needs to be replaced with the character 2. So maybe it's so efficient that the HTTPS server tells the HTTP client, the web browser, hey, you have on line 8 a 1, please replace it with a 2, and that's it. And then the last page is the weather, which contains a data grid. Let's see how that works. Route weather. This is stream rendering, which means that while the data for the data grid is being fetched, maybe from a very slow storage, such as a remote SQL server on a very slow computer, the web page will be loaded and it will say loading. Whenever the data is available server side on the HTTPS server, this HTML will be rendered. So table, table head, table row, table body, table rows with these things repeating. Once this is rendered as HTML via the stream rendering connection between the HTTPS server and HTTP client, the HTTP client will be notified that there's new content for this page, and now this content stopped existing on the page because forecasts is no longer null. Instead, this HTML content exists on the page. So I'm not sure if the entire page will be resent to the client, or if the client asks for the page to be refreshed, or if just the delta that says please remove one line with 1000 lines will be sent from the HTTP server to the HTTP client. Let's look a bit at the code. So the code is like this: weather.razor. This gets converted to a C# class named weather. This has a private field of type nullable array of weather forecast. There's a class defined inside of the weather class. The class is named weather forecast. This is a DTO, or how you name this thing, so similar to a struct without methods. So this is a property, another property, another property, and then this is probably a property that's just computed, doesn't have a setter, and the value is computed from the getter of temperature C method. And then the class weather has this method onInitialized async, which is a special method. It's being overloaded, it's being run by the Blazor engine. When it finds it, it's going to run it in asynchronous mode. It will wait half a second. During that half a second, forecasts is still null. In here is defined as null, nullable, and we don't assign any value to it. During 500 seconds, this page is sent to the HTTP client, so to the web browser. After 500 seconds, data is invented in this range. The forecast is being created, so it's going to be from 0 to 5, that's 5 elements. Random summary and a random temperature in degrees Celsius. Once weather forecast is no longer null, this thing gets triggered because we're in stream rendering. This part, this HTML rendered part, will be replaced with the HTML rendering of this part. Again, because of the for each, there's 5 times these 6 lines, so these are actually 30 lines of HTML code. And that's being sent to the HTTP client, to the web browser, with a request to refresh new data is available. And that's about it. This is a simple ASP.NET Core Blazor web app that does not use the web assembly. Next up, we can stop the debugging. So stop Shift F5. It says that if we navigate to, how do we close this thing. Collapse. Not sure. So program.cs, and then there's this play button in here where it says run project associated with this file, which we can select. Okay, it's the same thing. The application has started. We tried the counter. We looked at the source code. Okay, let's do these simple modifications that are suggested here. So it says that on the home page, home.razor, we should add a counter, which is again a class that's defined in counter.razor. So let's do that. Home.razor. After the plain text, welcome to your new app, we should add a counter. What are you doing? There's go to definition. If we control click on the Blazor type, goes to the file where it's defined, counter.razor. It's going to just render everything from here after this text, welcome to your new app. Let's start the debugging. Okay, let's see how .NET Watch works. Let's, I don't know, comment out. How do we do that? I don't know. Let's have both web browser visible at the same time. So we're on the home page. Let's see if we can edit something. The .NET Watch will apply this change. Yeah, but somehow we need to enable the support in Visual Studio Code for .NET Watch. .NET is a command line executable. I didn't find any way for having the changes that I do inside Visual Studio Code to be automatically reflected inside of the web browser, which is something that you would use the .NET Watch run command line for. There's this bit of help, which is Ctrl-Shift-F5 restart, which will open a new tab in the web browser. Okay, so this is how you would create a ASP.NET Core Blazor application. But then how do you run this thing in production? How do you run it without Visual Studio Code, without debugging configuration in production mode? So what we want is to have all of the C# source code, all of the Blazor source code, all of the code that can be compiled, get compiled to DLL files by .NET 9 SDK. But then those DLLs will need to find the non-source code file, the static files, so the content of the www root directory. And then also the files which are generated by the Blazor compiler machinery, so the CSS files with that globally unique ID like part before the prefix, etc. So for that, we actually want to not only build the Blazor App 1 C# project, but we actually want to deploy this project. Let's create a new Visual Studio Code terminal. Let's look at what we have right now. So we have a solution, a directory that contains a project, C# project extension csproj, and that looks as you would expect. So extremely skeletal, extremely few lines in here. Just says something about the programming language. So .NET 9, nullable, and implicit usings. The .razor files will be picked up automatically. The C# files, so the files with extension CS will be picked up automatically, are part of the project and will be compiled. Okay, again in the directory www root we have static files. And then in the bin directory we have files that have been generated by the debugger. We have by the compiler. We have run this project multiple times in the Visual Studio Code debugger, and in order to have the debugger running, we need to first compile the C# source code and the .razor files, etc. The output is this file, blazorapp1.dll, and maybe also appsettings.json. But these two files are not enough. We need at least also the contents of this directory to be available in the same place if we want the Blazor app DLL to work correctly. And then there's this file which doesn't have any extension and is marked as executable. Let's see what it does. So it's an ELF, so Linux native AMD 64, Intel x86 64 executable, which probably doesn't do much. It just runs the .NET runtime, plus it tells the runtime to load this DLL as an entry point, Blazor app1.dll. So this would be platform specific to Linux and ELF and AMD 64, whereas this thing could be cross-platform, Blazor app1.dll. Let's try to publish. So the command line is probably .NET publish. I searched on the net, .NET publish. And it would want to have a configuration file, a file that's named folder profile.pub.xml, which we don't have yet. So properties in here should be a file named publish files publish profiles directory, and inside there should be a folder profile.obxml. Let's just run .NET publish. Okay, so it says that it has compiled, generated all of the needed files, restored the NuGet packages, and then copied all of the needed files inside of this directory in bin release, then the .NET version, and then publish directory. Let's actually see what's in there. So Blazor app 1 bin release net 9. So you should always use the ms build configuration release, not debug any CPU when you're deploying your application. And then inside of the directory publish. So in this directory, the compilation took place of these files, whereas after the compilation was finished, the directory publish has been created, the build artifacts have been copied here, the needed DLL files from the restored NuGet packages that the solution and the project depends on have been copied here, and then also the static files. So the directory /ww root have been copied in here. Okay, and now we should be able to just run the application. Let's see that. So we have Blazor app 1. Let's see if we can run that thing. We don't have the web browser running. Okay, and now it's running a third type of configuration. So let's go through the configurations again. There's the configuration development HTTPS, which will use the port 7219. Development HTTP, which uses the TCP port 5102, 05 in this case. And then the configuration that's always there, that's hard-coded into ASP.NET Core, which is the non-development one, so the production one, HTTP only, and TCP port 5000, which we can see in here. It says listening on HTTP ://localhost 5000. Says the root of the web server. The environment is not development but production. And we can close the HTTP server anytime by pressing the Ctrl+C keyboard combination. Let's navigate to this URL. How do we move this thing away? And here it is. It's strange that the page title is counter because we have added the Blazor class counter here. In here, title counter. Okay, so probably the web browser tried to we told it to open HTTP protocol URL, and it probably tried to convert this URL to an HTTPS URL, but that does not exist, is not served by the HTTP server. Maybe that's why we have this warning. Fail to determine the HTTPS port for redirect. And this is it in broad lines, how on Ubuntu 24.04 you install the latest .NET 9 SDK software development kit. You can use that from a PPA that's maintained by Ubuntu themselves. How you can develop and create a web application. In this case using Blazor, but you can use any other technology that's supported by ASP.NET Core. You can use, I don't know, MVC, or you can use WebAssembly, Blazor type, anything. And then once your application is implemented correctly, you have the Visual Studio Code integrated development environment to help you create the application, to help you debug the application, to help you navigate source code, syntax highlight, autocomplete, etc. Once your application is prepared to be deployed, you will probably deploy it in a Docker container. But the way you deploy it is after the source code changes are done, you deploy your application by using the .NET publish command line. If you want additional configurations to the way you publish the application, that can be performed in a number of ways. You can use a very long .NET publish command line. You can provide the options at the command line. So one of the most important options in here is if you want to create a self-contained deployment with --self -contained true, or you want to create a framework dependent executable, which is what we did because we just run the command line .NET publish. -c release is an optional. You should always run the command .NET publish with the msbuild build configuration release. And then the third option is framework dependent deployment, where before the web application that you have created can run correctly, you will need to install the, in this case for Ubuntu 24.04, the dev package ASP.NET Core Runtime. This is it. Thank you.